So for HL, you have hypotenuse leg. Basically, that means that you would be spelling the bad word, ASS, but it has to be a right angle. It only works with a right angle, because if it's not a right angle, then it's not a right triangle, which means a hypotenuse does not exist, okay? Hypotenuse only exists in a right triangle. So in this case, we have angle marking, then a side marking. We are allowed to skip one, and then we go to the side. ASS, that's a right triangle, so this is HL. The two triangles are congruent by HL. Sometimes, a lot of the time actually, you're going to see triangles that are connected, okay? They'll look like this, where they share a common side. This triangle and this triangle share the side DB. Sometimes you see them connected like this, where they're sharing a vertex. They have these opposite angles. These are known as vertical angles. Hopefully you remember that from the last lesson, lesson 4.1. These are vertical angles. Here's another two triangles that are connected. They share a common side, okay? And sometimes they're separated like so. But when they share a common side, that's known as the reflexive property. You see, if we were to separate these two triangles, that means I'd be drawing one triangle down here, CDB, and another triangle up here, ADB. They share that side, DB. If I were to separate it, well, those lines, DB, would be the same exact measure because it came from this same common side. Therefore, it would be congruent to itself. And that's what these notes are saying here. If two triangles share a common side, then that side is considered to be congruent to itself. It's kind of like think of it as two classrooms that share a common wall, or just any two rooms, really. Any two rooms that share a common wall. All right? The wall on the one side of the room is the same length as the other side of the wall in the other classroom. All right? Vertical angles, we know that from the last lesson. Vertical angles are always congruent.